Hi, welcome back. So in this video lesson, we'll learn about test control. So just to remind you, we are talking about the first chapter of our Advanced Test Manager certification course, and that chapter is testing process. In that, we are talking about the first topic, that is test planning, monitoring and control. So before we talk about test control, let's think about this. So how does a project, a software project, large software project, get to be 1 year late? One, poor planning, insufficient staffing, unplanned changes in requirements, budget cuts, faulty programming, inefficient testing. So what do you think? How does a large software project get to be 1 year late? Yes, you are right. All of these can cause. So any of these factors could cause a project to get behind. Even small slips and mistakes in many areas can accumulate and result in long delays. So by continuously monitoring test progress, regularly reporting test status and dynamically adjusting test plans, you will reduce the chance that inefficient testing will be a factor in delaying your projects. So that is why test controlling is an extremely important aspect for test managers. So let us talk about it. So good measurement actually helps to effectively control. So by having a good measurement framework, you will be able to give feedback to your test team and other project stakeholders on test progress. That is one very important aspect of having good measurement. And also good measurements, if you have actual versus planned comparisons, then they can help you to control the projects well. And also the information to adjust test plans, including estimates for future testing activities. If you have good measurements, you can adjust the future test plans by incorporating the right actual values for a given situation. And also information about the overall quality of the system under development also can be achieved by good measurement. So good measurement is an important first step to really place good control in place. So keep that in mind. So good monitoring helps to effectively control. So test monitoring covers all the test management tasks related to checking the status of a test project and producing reports comparing plans with actual results. So good monitoring is essential to effectively control project, and good monitoring requires us to establish a good measurement and metrics framework in place. So good monitoring helps to effectively control. So a very visually appealing and visually effective kind of measurement framework and dashboards is an important activity, and the information entered into these various tracking tools, especially the test management tools and other tools, should be as accurate as possible, so that whatever you are seeing in your dashboards, those metrics, the trends, actually they reflect the reality. So that is why it's very important to establish good system. Now let us understand quickly. Again, this is we understood already in foundation level syllabus, but I am repeating for you. So what are the common test metrics? So test metrics broadly can be categorized into test metrics that can be expressed as simple quantities and test metrics expressed as a calculation. So for example, test metrics expressed as simple quantities or measures are like number of test cases run or not run. It can be expressed as a number. Number of test cases passed or failed, number of defects found and fixed, dates of test milestones scheduled versus actual. These are all simple measures, simple numbers, they are quantities. Subjective confidence level of testers calculated using some surveys. These are all considered as examples for test metrics that can be expressed as simple quantities. We can use these quantities and create another set of metrics, test metrics that can be expressed as calculation. What are the examples? Let's say failure rate, the ratio of number of failures of some unit of measure. Like you take number of failures by time, we call it as time to find a defect. Let's say you are calculating number of defects divided by the number of lines of code in a software, then we call it as defect density, expressed as defects per k-log. And there is another metric called defect detection percentage. Let's say you are measuring defect detection percentage for a particular level, let's say system level. Then system level DDP is equal to number of defects found during system test divided by number of defects found during system test plus all the levels that will follow this level. So that is how we calculate. These are all important metrics, but these metrics are expressed as calculations. So let us check your understanding on which metric below is a quantity based metric and which one is calculation based. So the first one is how much will it cost to execute and maintain tests. It can be expressed as a pure quantity, no need of calculation. So it is a quantity based metric. What is the failure rate of the system? Like how many defects are occurring per unit of time. So here we are doing a calculation. Yes, you are right, it is a calculation type metric. Are milestones being met? It can be yes or no, it's a pure quantity. So it's a quantity based metric. How long it will take to fix an issue? How many hours? So it's again not a big calculation there, it's a simple quantity. So then the fourth one is what percentage of the work still needs to be done for the project to be completed. So again it is a calculation based, because what percentage you are asking in this, so that you have to use a ratio of the work that has been completed and work that still need to be completed. So what is the coverage percentage? Is it a quantity based metric or a calculation based metric? So again, coverage is some type of coverage divided by the total number of things. So it's a calculation based metric. So hope you have understood what is a quantity based metric and what is a calculation based metric. Establishing a good metrics within the project early in the life cycle is extremely important. Again, we will talk elaborately on specifying, defining and establishing right metrics for a right project in the next chapters, but for now keep that in mind. Then next issue is the overview of test control. So test control is actually generally triggered by metrics and other data. Again, test control can be preventive or reactive. What do you mean by that? If you take few actions to control the project upfront before the event is happened, then we call that kind of test control as preventive measure. Whereas let's say the event has already occurred and then you are somehow adjusting, then it's called a reactive control. So test managers apply both of these things. Then again, test controls they're very project specific and they depend on what needs to be corrected. And they may affect an individual, the test team and entire project team. The actions coming out of this control activity can be anything. So typical commonly used test controls that affect the test team include, sometimes based on the situation, you may reschedule testing, or based on some situations you may add additional testers, or you can prioritize testing work and determining what not to test. These are all potential actions coming out of a test control activity based on the context and the situation. So test control is applicable throughout the project, and controlling actions, they are based on comparison of monitored information with the baseline. So that is the important point there. So typical example of a test control is let's say you are a manager, you have seen high number of defects being reported from one area of the software. Maybe potentially what you will do as a test manager, maybe you will put more effort into that area because you are finding more defects. So that can be one potential test control activity you may do. Let's say risk coverage and requirement coverage are inadequate. When you monitored, looked at the metrics, you found that we are not adequately covering the risks and requirements. So what do? Many things you can do, but one potential thing is you may prioritize remaining work and allocate more resources to achieve more requirement coverage and reduce residual risk. That can be your management action you may do. And let's say the third example is there, SPI in red. What is SPI? Schedule Performance Index. How well you are moving on your schedule. If it is in red, not happening properly, maybe one action can be more resources, greater use of tools. All these are potential actions. So that is how you control projects. You monitor, and when you observe the deviations, you will understand the reasons for the deviation and then take an appropriate action as a test manager. So before we conclude, let us do a check on your understanding. Let's say you are a new test manager of a company and you are developing a gaming software. You have taken several test control actions. For each of these test control actions, indicate whether it is preventive or reactive by selecting the appropriate radio button. So you have 4 situations, whether you are doing a preventive controlling action or you are doing a reactive. So let us read the first one. The ratio of failures on audio tests is high. So you decide to double the testing staff or audio options after the development team fixes the current problems. So you are in that situation. So here, are you doing a proactive step to mitigate the problem upfront, or after the event happened you are taking few actions? Yes, you are right. It is a reactive kind of controlling because the event has already occurred and the failure rate of audio tests, we are finding it is high, so you are adjusting that. So let's take the second thing. Designing tests for a new release is taking longer than expected. You decide to increase the number of testers designing tests. So you found schedule is slipping. So at that time you are taking a controlling action. So is it a preventive or is it a reactive one? Yes, you are right. It is a reactive controlling action. Let's read the third one. You are working with a new development team. You implement some additional static testing techniques in hopes of reducing the defects later in the project. So even before starting the project, because you are working with a new development team, you are implementing some static techniques early in the life cycle. So are you doing a reactive kind of control action or are you doing a preventive kind of action? Yes, you are right. It is a preventive action. The fourth statement, let's read. Marketing plans a big release before the holiday season. You increase the number of testers on your team so you can run additional tests before the product release. So you are expecting a lot of activity because it's a holiday season and there is a big release. Marketing is planning to release. So you are adding more testers to cope up with the situation. So are you doing a preventive or reactive? Yes, you are right. You are doing preventive controlling action. So hope you have understood this. So let us just quick recap on what is the activity called test control means. So the purpose of test control is to guide testing to fulfill mission and objectives. And it is an ongoing activity of comparing actual progress with the planned progress. We identify deviations such as behind the schedule or ahead of the schedule, or fewer defects or more defects, or early availability of a test environment or a late availability of a test environment. Like that you understand this deviation and then we determine appropriate corrective actions, either preventive or reactive. So hope you have enjoyed this session. So learn and have fun.